Welcome to Lesson 3. In this lesson, we will be exploring compound interest. We will be exploring compound interest by comparing it to simple interest and seeing how they grow. Our objectives are to understand the difference between simple and compound interest, as well as to derive the equation for annually compounded interest. Interest can compound annually, it can compound monthly, it can compound daily, but for this particular lesson, in order to better understand and compare compound and simple interest, we are just going to assume that it compounds annually. Notice in this chart below here, I have two lines. This red line that's straight, that's linear, represents our simple interest, while the blue line represents our compound interest. You can tell by the blue line that it is growing at a not constant rate. It is growing exponentially. That's why it's important to understand the difference, because if we have a savings account that grows at a compound rate, it's going to grow much faster than a savings account that only earns simple interest. Let's go ahead and look at another graph. Here we have a graph that shows an initial investment of $1,000, and you can see that right here. We have $1,000. If we did nothing, if we kept it in our drawer, that $1,000 would stay the same. You'll notice this principal stays the same, and I have circled $1,000. At the end of 20 years, it would still be worth $1,000. However, the problem is that over time, there's a cost of living, and that continues to increase. So at the end of 20 years, you may still have $1,000, but it wouldn't be able to buy as much. So we want to make sure to take our money and put it in some sort of savings account. This red line represents a savings account that earns simple interest. Notice that it does grow. It's growing at a constant rate. It's growing at 10% of $1,000, which is $100 every single year. So basically, if I invest $1,000, at the end of year 1, I would have $1,100. At the end of year 2, I would have $1,100 plus another 100, so I would have $1,200. And I would just keep adding 100, 100, 100 every year. So it's growing at a constant rate of change. So at the end of 20 years, I would have $3,000, which is still a lot better than $1,000. But look at what happens when we grow exponentially. This is our compound interest curve. Basically, what's happening when we have compound interest is that at the end of year 1, when we had that 1,100, interest is recalculated now on the 1,100. So the idea is that you are earning interest not only on your initial investment of $1,000, your principal, but also now on the interest you earn during that time period. So at the end of year 2, we have now earned interest on the 1,000 plus the 100. And then at the end of year 3, again, we would earn interest on the 1,000 plus whatever interest we had earned over years 1 and 2. What that creates is this exponential growth. Look what happens at the end of year 20. We now have $7,000. That is definitely huge and growing, much better than our simple interest calculation down here. I would rather have 7,000 than 3,000. All right, let's look at this mathematically. So here's our example. We had a principal of 1,000. We earn interest at 10% annually, and our time was 20 years. If we think about our simple interest calculation, in order to calculate our interest for simple interest, we simply take our principal, which is 1,000, times our interest rate, written as a decimal, times our length of time. If I multiply 1,000 times 10% times 20 years, I end up with $2,000 of interest. Of course, I want to know what my account is valued at. I want to know the value, the future value of my account. And the future value of my account is going to be the $1,000 that I initially spent, or invested, I should say, plus the interest that I have earned of $2,000. So as we saw on the graph, my value would be $3,000. Let's break this down as we will compound interest. Let's look at what happens each year. So year 1, under simple interest, we invested $1,000 and we earned 10%. So we basically earned $100 leaving us with a future value of 1,000 plus 100. So we had $1,100. But now look what happens. At the end of year 2, using simple interest, we still take our initial $1,000 and we still multiply it times 10%, that's our rate, and we still get $100. But now we have $1,100 in our account, and we add 100 to that, and our account is now valued at $1,200. So you can see that we start at 1,000. After year 1, we now have 1,100. After year 2, we have 1,200. And you can see the pattern. At the end of year 3, we would have $1,300. So it's only growing by $100 each year. Now let's go ahead and derive the formula for compound interest, or a simple formula, a quick way to estimate for compound interest. So here's the way this works. Here we have year 1. In year 1, we have $1,000, and we are going to earn 10% interest. So we are going to have $100 plus the 1,000 that we initially vested, which would leave us with our 1,100, just like with simple interest. But now here's the difference. Let's look at year 2. In year 2, I'm not going to start with 1,000 anymore. I'm going to start with 1,100. I'm still going to earn the 10% interest, but let's take a shortcut. Instead of writing 10% and then having to add back the 1,000, let's go ahead and write it as 1.1, which is 100% of what we had plus the 10%. And let's calculate it that way. If I go back to this problem, let's revise it. Now that you've seen how to calculate it, what if we took 1,000 times 100% of the 1,000 times our 10%? We would end up with $1,100. So we can skip a step if we take 100% of the 1,000, add it to the 10%, and multiply by that. So now we are multiplying year 2. We are starting with our 1,100 and multiplying it by 1.1%, the same as we did in year 1. And now you can see I put up a calculator that we would get $1,210. So what do you think is going to now happen in year 3? Well, at year 3, we are now going to start with the $1,210 times the 110%. So we would take this times 1.1, and we would get 1,331. So you can compare this to simple interest, and you can see that in year 1 it was the same because we are compounding annually. But in year 2, using simple interest, we only had $1,200. Using compound interest, we had $1,210. In year 3, we only had $1,300, but using compound interest, we had $1,331. And this would continue on and so forth. So really, if we try to derive this formula or think about this formula, we started with $1,000. We multiplied it by 1.1, and we got some amount. In year 2, we took this amount right here, which we knew to be 1,100, and we took that amount again times 1.1. And then in year 3, so we knew that all of this together multiplied to get us 1,210. So in year 3, we again took 1.1. So you can see that each year we just took our 1,000 and we multiplied, we keep adding a 1.1. An easier way to write this, to simplify it, and you'll see this in the next lesson when we actually do the formula, an easy way to write this is just 1,000 times 1.1 2x, the x years. If it was 1 year, I'd put a 1 there. If it was 2 years, I'd put a 2 there. Or if it was 3 years, I'd have a 3, depending upon how many of these I had. In the case that I have here, after 3 years, I would just write it as $1,000 times 1.1 raised to the 3rd power. I have 3 years at 110%. Now, one thing to keep in mind, I am using 1.1 because our interest rate is 10%. If, on the other hand, our interest rate was equal to 7%, I would use a little different calculation. I would use the $1,000 times 100% of the 1,000, but times 7% written as a decimal, which would be 0.07. So depending upon my interest rate, this second part here is going to match that interest rate. We will always have a 1 because we are taking the $1,000, 100% of the $1,000. The same thing that we did here, if you look back at the simple interest calculation, we had to take the interest and add it back to 100% of our principal. So this is just a quick shortcut. That concludes our lesson on exploring compound interest. So at the end of this lesson, you should be able to understand the difference between simple and compound interest. And you should understand that simple interest grows at a constant interest rate, whereas compound interest grows at an exponential rate because interest is calculated on both principal and the previous period's interest.